Bismillahirrahmanirrahim. Unit number 14, Current Electricity. Conceptual question from 7 to 11. Physics 10, National Book Found. Question number 7. Two electric bulbs, 100 watts, 220 volts, 200 watts, 220 volts have the tungsten filament of the same length. Which bulb will have thicker filament? Now the key point here is thicker filament means bigger radius or diameter of the filament wire resulting in bigger area. Remember, area of the conductor is one of the factors affecting the resistance of the conductor. Greater is the area, lesser is the resistance. The resistance of any material is given as R is equal to resistivity rho L divided by A. That means more length, more resistance, more area, lesser resistance. Now recall that one of the formula for the power dissipation of in electrical devices is P is equal to V square over R. So if we make R the subject in the above formula, R becomes equal to V square over P. Now note here, if we increase the power P, we will be reducing the resistance. That means in order to have more power, we need less resistance of the filament. So again, notice in the above formula, if power P increases, the resistance R decreases. Here, R is equal to resistivity L over A and R is also equal to V square over P. Greater is the area, lesser is the resistance, and to achieve less resistance, bulb with more power, that is 200 watts, will have thicker filament. Here the bulb with 200 watts will have thicker filament to have less resistance and greater area. Question number 8. Why are we advised not to touch electric switches with wet hands and first dry your hands? Note that dry human skin has a resistance of 1 mega ohms, that is 1 mega ohm. On the other hand, the wet skin has only about 1000 ohm, that means 1 kilo ohm. Wet skin becomes a very good conductor for the passage of electric charges through your body to grounds, which can be fatal even at times. So it is advisable to avoid touching the electrical switches with wet hands, avoid touching doorbell switches during rain, since it may cause current leakage through your body. Question number 9. Why is it dangerous to touch live wire while standing on earth barefooted? Recall that there are 3 types of wires in main electric supply in houses or industry. One is a live wire, the other is a neutral wire, and the third is the earth wire. It is only the live wire which carries the supply current to the load. I said it is only the live wire which carries the supply current to the load. So touching the live wire while standing on the ground barefooted would mean to provide the return path to the electric current through your body to the ground, hence putting the life at risk. Such an act can be fatal and one can die instantly. So it is always advised not to touch live wire standing on the ground barefooted. Question number 10. Sometimes if one of the car's headlamp is burnt or not working, but still second lamp gives light, what do you conclude about the connection of the headlamps from this observation? So mostly the appliances in a circuit are connected in parallel connections. May it be the house wiring or the wiring in the car's headlamps. Both the headlamps are connected in parallel, hence providing independent potential difference to each of the lamps through the battery. If somehow one of the lamps burns out, the second lamp still gives light because that is directly connected with the battery in parallel to the other and has no connection with the working or not working of the other lamp. So question number 11, it says, show that the volt ampere is equal to the watts, the SI unit of power. The electric power P is given as P is equal to VI. In SI unit, the potential difference are volts V and the units of current are ampere A. So we can write this as P is equal to volt ampere. Power is equal to volt ampere. And write this as equation 1. Now from the potential difference definition, V is written as work done per unit charge or even the energy used consumed per unit charge. The unit for work done or energy are joules. The unit for the charge is coulomb. So write it as J per joules per coulomb. This is the potential difference V. Write it as equation number 2. Similarly, current I can be written as charge per unit time or charge coulombs per second. This write it as equation number 3. Now from all these three, using all these three equations 1, 2 and 3, we can write volt ampere equal to, this volt is equal to joules per coulomb, amperes are coulomb per second. Once we write this, we can cut or reduce these coulombs with coulombs, resulting it volt ampere equal to joule per second, and you know the joule per second, that is energy per second, is watts. So volt ampere is equal to watts. This is proved here. This was the last question of the chapter. See you in the next chapter. Thank you very much.